So if you read along here, it says last section we covered absolute value functions, which were the form y equals a absolute value x minus h plus k. We all know that the minus means that you need to think opposite of whatever you see there, and plus k, you take it for what it is. We started out by graphing the simplest type of absolute function. The simplest one is y equals the absolute value of x, right? There is no h, there is no k. The a value, I guess, is an invisible one right there. Not I guess, I know is an invisible one right there. This is the simplest type of absolute value function. And this function is called the parent graph of all absolute functions. Okay, we're going to be talking about parent graphs today. Then when we did the absolute value functions that had a k value, it changed it a little. Then we did some with h, then we did some with h and k, then we did some with a, h, and k, which definitely changed, transformed is the vocab word that we need to use, transformed the way they look. So let's take a minute and open up our okay, so that's a typo. Let's open up our page, scratch out that right there. So let's open up our page of printed notes on absolute value functions from last week, and let's talk about how they transformed. So we're going to pause right here, and we're going to open up our notebooks, pull out 2.6 notes on graphing absolute value functions. This is a photo of the page that we're supposed to be looking at, the notes from last week on 2.6 absolute value functions. We should have a lot of V's graphed all over the place, upside down V's, upside down, they're a little narrow, opening up that a little bit wide, and so on and so on. So let's take a look at all of these, and this was the first one that we graphed. It was y equals the absolute value of x. Now, that is a regular parent graph. The a value is 1, the h value is 0. There is no number out here in front, so that's why the slope is up 1 over 1. So the a value is 1, there is no h value inside, and there is no k value. Okay, so the important point is the vertex, which is 0, 0 in this case, because hk is 0, 0. And we all understand this graph, right? Let's take a look at the next one that we did. This one had a k value of minus 2. So how about this? Could you guys describe the visual difference between this first parent graph and this new graph that has a k value of negative 2? What's the visual difference from this V up here to this V down here? What was that? It moves down twice, exactly. There's a shift, right? It's like taking this entire V and moving it down 2 units, and you have the same identical V, right? So what could we conclude of our k value? What is the k value going to affect? How's the k value going to affect your parent graph? In other words, if I had a plus 2 up here, if I had a plus 2 right here instead of a minus 2, what would it do to this guy? It would move it up 2 units, correct? Okay. What if it was a minus 5? What would it do to this guy? It would move down 5. It'd be way down here, the V, right? What if it had a plus 3? What would it do at the very end, the k value? It would move it up 3, right? So bottom line is the k values actually shift, or a different word for shift is translates your graph up and down. So the k value is going to be our vertical translation, our vertical shift up and down. Okay? Now, we already understand that the minus 2 right here ended up being the same V, but moving 2 units down. Now, what about an h value? Like this h value is positive 2. Remember, you need to think opposite of what you see in there. We see a minus 2, so the h value is positive 2. So what difference could you describe from the parent graph to this new graph? How does it change from here to here? It moves 2 to the right. Okay? So remember, the h value is positive 2, and that's why this v stays exactly the same, but it moves 2 to the right. Now, what if I would have had a plus 2 in here? What would it have done? If I would have had a plus 2 instead of a minus 2, what would that have done? it would have moved it, you see this dot right here? It would have moved it 2 to the left instead of 2 to the right. Because if it were a plus 2 in there, then you have to think opposite, which would be minus 2, which would move it 2 to the left, right? So the h value actually moves your parent graph up and down. The k value actually moves your parent graph left and right. Okay, so h and k actually shift your parent graph up, down, left, or right, depending on your h and k values. So if we look at number 4, which you should all have completed in your notebooks here, the h value is -1, the k value is 2. So the h, remember the h is a left and right shift, so the -1 is going to tell us that we're going to move to the left 1 unit. The k value is +2, that means you're going to move 2 up. Does that make sense? So our original v had the vertex right here at 0, 0, but after you move it 1 to the left and 2 up, you end up with that same identical v, but just shifted 1 to the left and 2 up. This guy over here, we're going to be shifting how? We're going to be shifting 2 to the right and 3 down. So the h value is +2, so it goes 2 to the right. The k value is -3, so it's 3 down. So do we understand how h and k affects our parent graph? Okay, 2 people. Sounds good. What about our... Now, if you don't have it complete, we need to complete it. What about our number 6 and 7 on last week's notes? So number 6, what's the h and k value? It's 0, 0, right? 0, 0. So it doesn't change. It still has the vertex at 0, 0, just like our original parent graph. Now, our original parent graph, let me do it in blue right here. It's 0, 0. Now, if we think about our original parent graph, y equals, let's say, the absolute value of x. That's the original parent graph. What is the definition of parent graph? It's the simplest type of graph of that family. So 0, 0, 1, 1, 2, 2, 3, 3, and it's also going in the other direction. There's a reflection from here. This is like the axis of symmetry, like a mirror, and there's a reflection on the other side. So there's our original parent graph. Whoa, that's ugly. So what could you tell me if you compare the original with this new a value of 1/2, which is out here? The new a value of 1/2 caused it to change to this. What did it do to the original parent graph? What did it do? You had the original right here in blue, and then the a value changed to 1/2, and it kind of it widened it up, right? Okay. Now let me do the original parent graph in blue again on this next one, number 7. Let's say y equals the absolute value of x. That's 0, 0 because the hk is 0. It's up 1 over 1, up 1 over 1, up 1 over 1. Let me do the same to the other side. There's the parent graph. I'm not going to draw it completely. But now let's compare it with this new one that has this number 7. What hk value does that really have? 0, 0. Okay. Now what do I do from 0, 0, which is right here? What do I do from 0, 0? Up 3, 1, 2, 3, over 1. And I could go up 3 and over 1, but I'm already going to be off the graph. And I need to reflect it on the other side. So what do I have? I have this type of V. So ladies and gentlemen, what did the a value of 3 do to the original parent graph of a value of 1? It made it narrower, right? You guys follow me here? So we need to come to some conclusions here that the h value, any h value is going to eventually be a movement of your parent graph left and right, and any k value is going to be a movement up or down, and any a value is either going to be a stretch or a compression. Let me repeat that. It's either going to be a stretch or a compression. Now there's vertical stretches and vertical compressions. So if I take a look at my original parent graph that's in blue, and my a value dropped to 1/2. It was 1 in blue, and it dropped to 1/2. So obviously it opened up, it got crushed. It was a vertical compression. Okay? Now, what do you think would happen if this would become 1/10? 1/10. Or let's not even go that crazy. Let's go 1/5. What would that look like? It would look like this. Let me do it in purple. So let me go y is equal to 1/5 absolute value of x. So that's going to be this wide now, because up 1/5. So what could you guys tell me with regards to the a value? Here's the a value of 1. Here's the a value of 1/2. Here's the a value of 1/5. What would 1/10 look like? Dang, it would be really crushed. You guys see what I'm saying? What would 0 look like? It'd be a flat line. Okay? Now, if you increase a, so here's 1/5, which is hardly anything. If you had 1/5 of a tank of gas, it's not much. But 1/2 of a tank of gas, that's more. 1 full tank of gas, that's more. So as your a is increasing, it becomes a vertical stretch. So it gets narrower and narrower. That's why over here, the a value of 3 causes it to be pretty narrow. Now, if I said the a value of 5, like let's say I said y, a value of 5 in front of the absolute value of x, then it would be up 5 over 1, and it would be even narrower. Does that make sense? So the a value causes it to become wide, or it causes it to become narrower. The closer the a value is to 0, well then the wider it gets. If it's actually 0, it just becomes a flat line. But the closer it gets to 0, the wider it gets. The bigger the a value grows, the more narrow the v value gets, which is ultimately a vertical stretch or vertical compression. If you say vertical compression, you're talking about it widening up. If you say vertical stretch, it's talking about making it more narrow. So I'm going to leave it at that with regards to transformations. So going back to our notes from today, after reviewing that page of different graphs of absolute value functions, let's state how h, k, and a affect the parent graph of y equals the absolute value of x. So we should all write down right here on h that it causes the parent graph to move either left or right. And you might also write, but you need to think opposite on h. And what about k? What does that do? It causes what kind of shift? A vertical, up and down, right? So we're going to say causes a vertical shift. And last but not least, what does a do? A causes what? It causes a vertical stretch or compression. A vertical stretch or compression depending on the value of a. Oh yeah, and there was one more that I forgot to go over on the worksheet. That was if your a value is negative, right? So if you think about y equals negative absolute value of x, it's the same thing as your parent graph, which would open up like that, but what the negative one does, it reflects it on the x-axis. So it would actually flip it on the x-axis, okay? It would make it open down instead of up.